All right, the plan for today is we're going to finish the PowerPoint that we started yesterday, picking up with this page right here. So this is concentrating on calculator keystrokes, excuse me, knowing what to do when. So instructions are to solve each of the following. For the first problem right here, we have x is equal to the tangent, and our angle is given in degrees, minutes, seconds. The variable we're solving for is already by itself on the left. So the only thing we're doing is typing this expression in using the correct keystrokes on the right-hand side. So I'm going to go to mode, make sure I'm in degree mode. Graphing calculators, remember, default to radian mode. If the answer you get in radians will probably make no sense. So I'm good to go with that. So I'm going to type in tangent, 40. I'm going to go to my angle menu, which is the second above apps. I'm going to grab the degree symbol, 31, back to that same angle menu, grab the minutes, 17, and then one of the weird quirky things of this calculator is the second function is not located in the angle menu. We have to go down here to alpha plus in order to get the second symbol, rather. All right, this particular page does not have any rounding instructions associated with it. If there are rounding instructions, always make sure to follow them. A safe way to go is if you're answering the ratio, meaning the thing that you get after you do the trig function, 4 decimal places is always a safe thing to round to. So our final answer for here to 4 decimal places will be 0.8547. I'm going to zoom out a little bit here to give it a little bit more room. I think that should be good. All right, second problem here, the cosecant of 12 degrees, 15 minutes, 50 seconds. So the fact that the variable is by itself means we just have to get this typed into the calculator. Well, we don't have a cosecant button on our calculator, so what we have to do is use the reciprocal function. Cosecant is the reciprocal of sine. So we're going to type in our calculator 1 over the sine of that angle. So 1 divided by sine, 12, angle menu to get to degrees, 15, angle menu to get to the minutes, 50, angle menu, no seconds. We have to go to, get to the end of that again. Alpha above the plus to get the seconds. And again, if there are rounding instructions associated with this, make sure you follow them. There are none here. The safe way to go when answering the ratio is to 4 places. All right, numbers 3 and 4. Here we know the ratio, but not the angle. The angle itself is what we're solving for. This is when we use our inverse trig functions. So what we're going to type in a calculator is the inverse cosine of 0.940. Inverse cosine, its notation is that little cosine with a -1. So I am going to go to second, get the inverse cosine, type into 0.940, and this is an angle measurement. Usually with angle measurements, 4 decimal places is a little bit overkill, especially if you're in degree mode. With degree mode, usually 2 decimal places will get the job done. So the theta is about 19.95 degrees. All right, now here's something that is a point of confusion, which is why we're doing this one particular page here to sort it out. In the trig world, that -1 exponent doesn't mean put it to the bottom of the fraction. In other places in the math world, that's what that notation means. In the trig world, this means that you are trying to find the angle when you know the ratio. It's used to solve a problem like that. It's not being used like we flipped here. So that's just something you have to sort out in your own mind in making sure you're aware of the difference. When you're doing the reciprocal trig functions, like here, this is when you're putting things top and bottom in a fraction. When you're looking for the angle, that's when you're using that notation there. All right, number 4, that blends the two concepts together from above. If we had a calculator that had an inverse cotangent button on it, we would type in the inverse cotangent of that decimal. We don't. So what we have to do is translate this into a trig function that we have a button for in our calculator. Tangent is the reciprocal, cotangent is the reciprocal of tangent. So I'm going to rewrite this as the tangent of theta is equal to 1 over 4.753. Okay, rewriting tangent and cotangent is effectively flipping the left side of the equation. If you flip the left side of the equation, you have to flip the right side of the equation. Now, we're going to type in the inverse tangent of that fraction. And that will give us our final answer. So second tangent, to get an inverse tangent, 1 divided by 4.753. It's an angle in degrees, 2 decimal places is a safe rounding, get 11.88 degrees. All right, 5, 6, 7, and 8 all follow the basic same format as 1 through 4. You're on your own to try those if you feel like you need to practice. I'll write down the answers. 0.9969, 11.0415, 47.55 degrees, 21.32 degrees. All right, now on to some word problems. It says the angle of elevation from a hiker to the top of a mountain is 25 degrees. After the hiker walks 1,000 feet closer to the mountain, the angle of elevation is 28 degrees. How tall is the mountain? All right, well, 2 terms you need to be familiar with before we start this problem: angle of elevation, angle of depression. The angle of elevation is always between the ground, or whatever the bottom of the problem is that's being defined, and the thing that's going up. In this case, it's a line of sight. What's going up could be an actual physical object, like maybe a support wire or a brace or a ramp or something like that, but in this case, it's just a line of sight. Now, in contrast, an angle of depression is always between the horizon and whatever goes down. So the angle of depression would be up in here somewhere. And we're going to get to those next slide. All right, back to this problem at hand. So what we have here is we have a bigger outer right triangle and a smaller inner right triangle, but they share this side in common. So that side is what we're looking for. That's the height of the mountain. They've already labeled that x. All right, what we're going to do is set up 2 equations. If we look at just the smaller of the right triangles, in relation to that 28, the x is the opposite. What I'm going to need to do is introduce another variable to this problem. If there's already an x, this can't be x as well. Okay, be careful to what's already been defined. You can't have 2 different x's representing 2 different values in the same problem. If there's already an x, you need to make that a y. So one equation I can write is I can write that the tangent of 28 is equal to x over y. All right, now what I'm going to do is I'm going to go to the bigger right triangle. So in relation to this angle, the 25 degrees, the x is the opposite, and then the adjacent is going to be 1,000 plus y. So another equation I can write is the tangent of 25 is equal to x over 1,000 plus y. So what I have is a system of equations, two variables. I can solve this for x, I can solve that for x, and then set those two things equal to each other. So x is equal to y times the tangent of 28. X is equal to the quantity, 1,000 plus y, times the tangent of 25. So if x equals this and x equals that, we can set these guys equal to each other. Now, although our final answer is going to be an approximation of some kind, we would like the approximation to be as accurate as it can be. So I'm going to avoid intermediate decimal approximations at this part of the problem. What I'm going to do is solve this for y, keeping it as exact as we can keep it. So on the right, I'm going to clear parentheses. And then I'm going to get my two y terms to the same side of the equals. So that y tangent of 28 stays on the left. And I'm going to bring this guy over as well. I'm going to factor that y out. And then divide by that binomial. All right, so at this stage now, I'll get my decimal approximation. I've kept that as accurate as I can up to this stage of the problem. So the way I'm going to type that in, 1,000, tangent of 25. I need to close the thing I'm taking the tangent of, divided by, and that whole quantity on the bottom. So tangent of 28, close parentheses for the 28, minus the tangent of 25, close parentheses for the 25, and then close for the entire thing. So that gives us a y value of about 7129.89. Now, just because we solved an equation doesn't mean we answered the question. So I want to go back and see, well, what do we know? Are we done? Or do we still need to find something else? So it's asking us for how tall is the mountain? Well, how tall the mountain is x. We found y. We found how far it is from the guy at this stage of the walk up to the base of the mountain. So what we need to do now is to get that y value. Get the x value that goes with that y value. So I can plug this number back into either equation and then solve for the variable, or one of the solved versions of these two guys. So the quickest, easiest one to do would be this one right here. I know x is that 7129.89 times the tangent of 28 number. Now, I already have that number saved in my or left over in a calculator from the last step. So what I can do now is just multiply that times the tangent of 28. All right, it didn't specify rounding. If there's a specified rounding, make sure that you follow it. In this case here, the nearest foot is probably acceptable. When you're talking about something that's over almost 4,000 feet tall, rounding to the nearest foot is probably a reasonable rounding. So that height of the mountain is 3,791 feet, or approximately that number rounded to the nearest foot. Okay. Another place to be careful with in this problem. One thing I already mentioned, if there's an x, there can't be another x. Other place where students make mistakes where I can't follow work. In these equations over here, I have a y. If you're going to have equations to solve a problem, that variable needs to appear in a picture, or needs to be defined, or needs to have some meaning to what I'm doing. I'm not going to go figure out what is your y. If you have a y in equations here and there's a picture, you need to show me where y is. Just like if there are two different x's and they don't represent the same quantity, I'm not going to guess which is which. You have to be clear in terms of how the variables line up with what's in the picture. All right, next word problem. A sightseer on vacation looks down into a deep canyon using binoculars. The angles of depression to the far bank and near bank of the river below are at 61 and 63 degrees respectively. If the canyon is 1,250 feet deep, how wide is the river? All right, so our angles of depression are always between the horizon and what's going down. So the angles of depression are 61 and 63. Okay, the canyon is 1,250 feet deep. They already have variables defined in a problem. X is from here to here, and that Y, that's the length of the river. That's that little river in the middle of the canyon. So that's what we're shooting for. That's our final answer. All right. Now, if this is 61, that angle from there to there is 29. If this is 63, that angle from there to there is 27. So if we're going to use these triangles down here, we either have to make that adjustment with the fact that we have right angles, or use these angles down here as alternate interiors. You can't use the 61 and 63 with those triangles as is, because those 61 and 63 degrees are not part of the triangles that we have in the picture. All right, so what do we know? In relation to, we'll do the smaller triangle first, this 27 degrees, we have, that's opposite, that's adjacent. So we got a tangent equation again, similar to the last problem. And in relation to that 29, we have the opposite would be x plus y over the 1250. So those are going to be our two equations that we want to be working with here. So the smaller triangle, the tangent of 27 is equal to x over 1250. We can solve that equation. We can get a number for x. And the other equation, the tangent of 29, is equal to x plus y over 1250. So what we can do is we can get that x, plug it in there, and then we can solve for that y. So on to the calculator here. We have, this is going to be 1,250 times the tangent of 27. And we get about 636.91. I'm going to give a little bit more decimal places, or a couple more than maybe you would really need in the final answer, because we're going to be using that as part of the next problem. So now, got the tangent of 29 is equal to 636.91 plus y over 1250. So we can multiply both sides by the 1250. And then subtract that 636 number from both sides. And that will give us the y. So we have 1250, tangent 29, get that quantity, subtract the 636.91, and that gives us a y value of about 56 feet. And again, talking about this type of problem, rounding to the nearest foot is a pretty safe thing to do. You could keep a decimal place or two more accurate if you want, but typically these problems, if there is a rounding instruction, to the nearest foot would be sufficient or common. All right, one more word problem. A hot air balloon is seen simultaneously by two observers at points A and B that are 1.75 miles apart on level ground and in line with the balloon. The angles of elevation are shown here. How high above the ground is the balloon? All right, well, that triangle that they're giving us is not a right triangle. Right now, we only know right triangle trig. Soon, we're going to expand out to cover law of sines and cosines. Some of you may know law of cosines and sines from other math classes. If you know how to apply it here, you can. I'm going to roll with the only thing that we know is right triangle trig. So what I'm going to do is I'm going to introduce another feature to the graph. And this is helpful because breaking this up into two triangles this way also puts that variable of the height of how high above the ground is the balloon. So now we have a right triangle over here. We have a right triangle over here. All right, next move is we need to break this 1.75 miles up. If both those angles were exactly the same, we'd have a symmetry thing going on, and we could break that 1.75 exactly in half. They're different, so we don't have that luxury. So what I'm going to do is call the left part x. That makes the right part 1.75 minus x. Because whatever this is, they have to add up to be a total of 1.75. All right, now I'm going to set up two equations. For the triangle that's on the left, I can go the tangent of 33. It's equal to h over x, opposite over adjacent. For the triangle that's on the right, I can do the tangent of 37 is equal to x over that binomial. Oops, not x, h. I apologize, h over that. So I can solve this for h, solve that for h, if h equals this and h equals that, we can set these guys equal to each other. Now I'm going to do a similar thing. Not a similar thing, different type of problem. I'm sorry. I'm going to solve for x. I'm going to need to clear parentheses. At quick glance, I thought this had the same algebraic structure as two problems ago, but it's a little bit different. I want that by itself, so I'm going to get this over here. And I made a mistake. I know what I forgot. I lost that x. It did have the same algebraic structure. I just had a little copying mishap. Let me fix this. I apologize for that. It does have the same. I want to get the two x's to the same side. This has to come over here. Factor out the x. Divide by the binomial. Okay, when you type that in your calculator, you want to... Ooh, I made another mistake. I'm having a tough time on this problem. It was minus becomes a plus over there. All right, when we type this in our calculator, be careful with the parentheses. Make sure you get them set up like we did 2 problems ago. Round to something reasonable. If this was 2 decimal places, you probably want to go maybe a little bit more than 2 decimal places, maybe at least 2 decimal places, just to be on a safe side. Turns out to be about 0.94 after you type that in your calculator. With any word problem, you want to make sure that you're answering the question. Here, they're asking us how high above the ground is the balloon. That's the H. We answered for the X. The X is how far it is from this guy to the spot directly underneath the balloon. So what we need to do is plug that 0.94 into something that allows us to solve for H. So this equation up here will be the quickest. Plug that X in there, so we got about 0.94 times the tangent of 33. So we'll do the 2 decimal places, and we get about 0.61 miles. We didn't have any variables pre-labeled in this problem. There's nothing here that specifies what a variable needs to be. So it's your choice in terms of what variables you choose to use. I chose to use H and X. As long as whatever variables you're using here, I can cleanly follow in whatever is labeled in the picture, it's fair game. You could use A and B or whatever you want to use. Just make sure that you're not repeating variables. If there are 2 different values, they can't both be the same letter, and whatever letters are here, they're clearly shown in the picture. All right, that more or less wraps up what's going to be considered our Unit 1. This Unit 1 is basically a review of some basic geometry trig, introducing the 3 new trig functions, and then expanding it into some word problems and some higher end things that you did see in geometry, but the inherent core information is basically just an extension of geometry. The next 2 days, whether you will be in class or not, depending on which group you fall under, will pretty much be review. There might be some minor extensions or variations of what we've talked about, but for the most part, you can expect that this more or less wraps up what you need to know for the first unit test, and I will be giving you more information over the next 2 days in terms of what you need to know and not need to know, format of the test, etc.